Okay. So the exception is, I think the one I just said it. Okay. Is if we're on a horizontal like this, not on an inclined plane, horizontal, then it's the exception. Then if parallel will be cos and if perpendicular will be sin. But if it's at an angle, like I think the one here at the bottom, if it's at an angle like this, then it's like I told you, where perpendicular will be cos and parallel will be sin. Okay. Right. Next one. They say there, determine the horizontal and vertical velocity components. So what is happening here? Here we have a rocket and it's being shot up into the air. It's being shot up at 200 meters per second at an angle of 50 degrees. Okay, so I'm going to draw the picture on here. So there is our vector. And we can split our vector into its perpendicular components. So we have an x component there and a y component there. Okay, now since the x component is horizontal and the earth is horizontal and they have the same line going through there, then these two angles must be the same. Ne? From mathematics? Yes. So this angle here is 50 degrees and that is 90 degrees. Okay, Mama, which one do you want to calculate first? X or Y? Okay, so she wants to calculate x first. How will you calculate that? Sin, cos, or tan? Say again? Yes. So the cos of 50 is x over 200. If you rearrange that, x is 200 cos of 50. Does the rearranging make sense to you? Who says no? Okay, because remember you must ask. Things that I go through fast, I assume you know, but sometimes you have an off day or you really don't know or whatever. Okay, and this is not newtons, this is meters per second. Remember, velocity is still a vector. It doesn't have to be newtons. Then if we calculate y, Tiamo, how will we do that? Sin. So the sin of 50 degrees is y over 200. And that gives you 153.21. Okay. Then the next one is there's a ball that will be rolling down the incline and they just ask you to take the weight component, Fg, weight, and you must get the component parallel to the incline. Okay, so if you draw in that force, remember Fg is in what direction again? Towards the center of the earth. So you always make it down, 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 down until it touches that thing. Okay, now just a clue, or not a clue, a tip for the future. If you want to draw in Fg, draw it on the side closest to the angle. Draw in Fg there. Okay, it just makes it easier to look at your triangle. Okay, then you want to split Fg into its perpendicular components. The one is parallel to the incline, the other one is perpendicular to the incline. So what do? You start with the perpendicular. You put your ruler so that it looks like that. The ruler. Perpendicular to the incline. Put your ruler like that. And then you take your ruler down so that you can elongate it until there. Not until it touches there at the bottom. Not all the way. Just until there. So that it is perpendicular to the inclined plane. Okay, so you call that FG perpendicular. Then you take your ruler, you put your ruler on the inclined plane like that. And then you take it down and you draw in there. That is called FG parallel because it's parallel to the inclined plane. Okay. So this is quite important to me that you get this drawing right. So I'm going to come around and check each of your drawings. So while we are busy with that, I want you on your own to calculate the component parallel to the incline. I just want to give you a few tips. This here is 30 degrees there at the bottom. And they tell us the weight is 60, so FG is 60. Okay, so I'm going to come around. I want you to try that. I just want to check your triangles that it is the correct shape. Drawing your 90 degree. Okay. I just want to make this clear once again. So this is why I went around. This is very, very important. They are called what components to one another? Perpendicular. So it means they must be perpendicular to one another. That must be clearly seen in your sketch, and you must show that to yourself. They are perpendicular to one another. Okay. Right. So if you want to calculate the parallel component, it will be the sin of 30 will be FG parallel over 60. Now I told you don't have to write it like that. You can immediately just write FG parallel is 60 sin 30, and if you calculate that, you get 30 newtons. All right, so you know what your homework is? Those 3 questions, please.